So for me, I did an interview at one of our local hospitals a few years back, and some of the programmers that I interviewed with, their systems people, told me that they were moving a bunch of stuff to Linux systems, and they were really worried because they didn't know how to do backups. So they've had stuff running on these Linux boxes for several months, but they didn't have any good backups because they didn't know how to do it. And so, of course, they wanted to know if I knew how to do that. Yeah, I know how to do that. It's kind of an important thing. And then I talked to the new guy in charge, the new president, and he said, yeah, we're really excited. We're going to move all of our heart monitoring equipment to these Linux servers. And I was like, no, I don't think I'm interested in going to work for you guys. It seemed like they were jumping the gun a little bit on that technology when they weren't really quite ready to start using it to run people's lives. Okay, I want to create a new project here. I know you guys created that one last time, and you can keep using it if you want, but I didn't create one. So I'm going to create a new project. I want it to be a console app. And I think I'm going to name it CH4A because it is chapter 4 in our new book, but it is the arrays section. So I'll make it 4A so it stands out a little bit. And we'll just call this array practice. Get my project open here. From earlier. The first thing in our project that I'd like to have is an array of strings. So how would we begin coding that so that we could declare an array of strings? That sounds good. Let's rename program.cs here while you guys are doing that. And I'm going to name it basic string. Because we're going to be using a basic string array here in this one. Great job. We start with our data type followed by our open and close square brackets. Somebody asked this morning if there was like an official name for those. Does anybody know? I thought they were square brackets, but I'm sure there could be some weirdo name. Do I? Now I'm going to call this array name, and I want to give it some initial entries. So let's just put some names in here, some nice short ones. I want Joe and Sam and Bill. That should be enough. Just a few names in our array. We saw last time that we could use the ForEach loop to easily traverse an array, like to print out all these entries. So let's do that for this array. I think that I'm going to fix my using clauses and add the using static system.console so that we can make that code short. So I'm going to start it with my for each, and then with our for each criteria, if you can't remember how to do it, you can always start at the end with what you want to be looping through. So I'm looking at everything in my names array. Now, before that, I'm going to tell it what data type I'm looking at and give each thing in my names array a name. So I'll call each of those item. So I'm going to say for each thing in my names array, make it a string and call it item. And then I can just do my simple write line on that item. I want to label the closing curly brace. That's the end of my for each. And then after that, I'm going to put in a read. Now you should be able to try it. And we should be seeing the 3 names in our array print out. So great. We can do that super easy then. We know what to do. So after our array has printed out, we're kind of developing this as we go. Let's update one of the entries in our array. Let's prompt our user or ourselves for a new name. Yeah, it's ourselves. Please enter a name. And then I'm going to create a string variable to hold that name. We'll call it one name. Read that into that variable there. Now, if I want to put that name that I just read into the first position in my array, how would I do that? Bracket 0, like that. Square bracket. Right, so I can just put the square bracket 0. That's where I'm starting to. We really want that entry from our names array. Very good. And then we want to assign a value to that. And the value we want to assign is our one name variable. So that should update that entry in our array. Now let's print it again and make sure. I'm going to do a write line first of kind of a heading. I'll say updated ... And then my ForEach loop. This time we can say string thing in names and write line our thing variable since we called it something different. Sometimes when we're working with C#, it can be hard to determine where the name of something is. So I'll try to give you examples that have multiple names, and then we'll go back and change them. So let's run this. We should be seeing our 3 original names, then seeing a prompt for a new name. I'll put in a new name. And then in our updated output, we should see that new name first.
Is there a way to get it to not replace the first one in the list with the new name?
Sure, you could create another array, put that new name in it, and then copy everything from this array into that one.
But you can't really update the length of that same array. You have to dump it into a newer, bigger array.
And once something is in that spot, the only way to change what's in that spot is to put something else in there. So you could do some logic, but you would have to do it programmatically. You can't just like anything. So we got other C# construct structure, but not with just a basic array. So that's why you guys have to use the basic array in this chapter. Yes, sir?
Suppose hypothetically we initialized our names array and then reinitialized it with the same name but with new values and maybe a different number of values. Would that make it throw a fit, or is that a thing you could do?
You could do that.
So you could then make a method and make it so that string names equals update array with your names of names as, and then in that method it would do that thing where it makes a new array with the old values of the array and additional values you want to put in now, and then pass it back.
You could do that.
So you could sort of work around it, make additional work.
It would take some additional work, and a lot of people actually have a lot of code like that in systems that are really, where performance is really, really important, and they don't use some of those newer, more flexible constructs that let you insert into an array. Because you think about it, if C# has a class that lets us insert into an array, which they do, C# itself internally is going to have to do all that moving of all of those entries that already exist. So does it do it more efficiently than you? Some people think they do it more efficiently, so they put it in their own code. You could probably do a lot of different testing to see.
I think it ultimately depends on what you're doing in that array and how many things are actually in it.
Yeah,
Like
how
for
often
small
you
things,
need to insert
whatever
things.
works.
Mm-hmm.
It might be less efficient, but you're only doing like 5 or 6 things. You're not going to notice the difference.
It's not going to be as big of a deal.
Whereas if you're an insurance company, for instance, that has umpteen million policies you're trying to get through, and you've got those in a big database, you want to be as efficient as possible.
Yes. Now, what I want to be efficient as possible with is, I see duplicate code here, right? So shouldn't we make a method out of this ForEach loop where we're printing out our array so that we wouldn't have to duplicate that? Let's do it. Let's create a method. I want to locate the closing curly brace for my main. Here's my end of my main method. And then I'm going to create a new method. This method is void because I'm not going to return any output. We're just going to print out what's in our array. So we'll call it print array. But we are going to need the array passed to us as a parameter so that we can print it out. So we will say we need an array of strings passed to us. And within our method, we'll call that array INP for input. Now in our print array method, we just need that for each loop. So for each string item in our input array now, because it's not going to be our names array since we're down in our method where we gave it a new name. And we're going to write that out. So let's call our new method. I want to replace this second for each that we had before. I'm going to select all of it and replace it with a call to our new print array method. Now in our print array method, we are supposed to pass in an array of strings. That array of strings that we have is our names array. Let me indent there. Oh, it indented for me. Well, I think I have everything right, but it's giving me an error. It's saying that what? Remember, whenever we're using our main method, that's a static method, we have to call other static methods. We can't have instance methods that could have multiple occurrences in memory. That's why we like using classes, because with classes, we can create methods that are not static. Okay, so we're going to make a static function. And now I don't have any errors when I'm calling it. So let me change the first for each loop in our main to call this method. We want to pass it names again. Now our main looks much cleaner, doesn't it, without that for each loop in there. It would be even better if we created a method prompting for that input, huh? That's all right. We don't have any duplicate code there. So let's run it and make sure we're getting the exact same results. Dated everything coming out right. I'm getting two outputs and only two, no extras. Good, everybody good? Remember, if you accidentally left your ForEach Loop up here in the main, you might get 2 sets of them. You guys didn't do that, huh? Good job.
I have 3 people.
You have 3 people? Yep, you should have 3 people.
Oh, okay.
Oh, you should just have 3 people printed twice.
I have 4 people.
If you added another person, that's okay. He wanted another one. All right, after we did that update, let's do one more update. In this update, I want to
I have an
Same
arbitrarily
thing.
large number of people.
we want to set the second entry equal to the third entry. So in my names array, if I want to update the second entry, what index value should I use? 1. And I want to set that equal to the third entry. That'd be my index value 2. Now I could write a line again, and this time I'll say swapped. That's kind of the technical term for if we switch positions like that. We didn't really swap them though. So I'll print array names. Now you should see all 3 of your names 3 times. Your third time, that last name should be there twice. So that wasn't a very good swap. We need to add more to this code. How could I actually, I want it to where they're switching places. So could I say names sub 2 equals names sub 1? Would that work?
No,
Why not?
because sub 1 by that stage already equals sub 2 anyways.
Exactly. So what could we do? We almost need a new variable
Yeah,
to hold that.
you need a temporary holding spot to put things in.
We'll use this temp variable to hold that second entry. And then we use that temp variable to finish our swap there. And that is a common thing that we have to do often with arrays, depending on how we're, what kind of thing we're doing with them. Now we should see those 2 actually switching positions instead of just bill out there a bunch of times. That looks better. Now we truly did swap them. Okay, so this is just some pieces, right? Just a few more pieces again, like last time. Just some little samples. When you're thinking, oh, I know that it's really easy to get to that entry in the array, but I just can't remember how. Hopefully these little pieces of code will help you do that. So remember to refer back to it. Let's save all on this, and let's create a new project unless you have questions about this one. If it's looking good to you. Last time, some of you may have already left. I posted a PDF document to our announcements. If you bring that up, it's an older textbook. It's actually a textbook that we used to use. This is a very old version, so it's freely available now, so that's why I was able to post a PDF for you. Our new textbook does not present things in the same way as this one does. So even though it's a little out of date, it might be beneficial for us. In this book, chapter 7 talks about array. So this next project that we're going to do real fast is something that you need to know how to do to look through the projects in that chapter. So if you want to step through those projects, that would be really, really helpful to you. But I need to make sure you can follow along. So we're going to do this little one to get you there. So our new project, I'm going to right click on our solution and choose Add New Project. And I'm going to leave it as a console app, but I'm going to call it Windows Message Box. In the next couple of weeks, we'll be finishing up with all of our console-based things and working towards our forms-based or GUI-based things. And this message box is just kind of a little preview. Now the program.cs file, I want to rename it also to Windows Message Box. Now, in order to use some of the forms-based tools that are available to us, we need to add a using statement. So we want using system.windows.forms. We can put a comment there. Now, it's needed for the message box, but I'm getting an error on it. We haven't ever gotten an error on a using clause before. It says this directive is unnecessary. Something's missing. Are you missing an assembly reference? Well, yes, we are, and that's exactly what we need. If you look in Solution Explorer at your project, do you see this thing with references? We want to add a reference. Now, just like all of the other components in Visual Studio, there are lots of ways to do that, and I'm a right clicker so that students can see what I'm doing. So I'm going to right click on References and choose Add Reference. Now, the Reference Manager utility is kind of clunky. It shows us hundreds and hundreds of Microsoft available libraries that we could pull into our project. We're looking for windows.forms or system.windows.forms. So scroll down, it's all in alphabetical order. You should be able to find system.windows.forms. Now, when you find it, when you mouse over it, the checkbox control will activate so that you can click it. And we want to check that.
Windows.systems.forms. Yep, there it is.
Got it?
I had the order wrong. Oops.
Yeah.
Well, I'll just do it again, I guess.
Click OK. Once you find it, and now in your references, you should see system.windows.forms. We've not really looked at the references before, so it's not something you're familiar with to know that it's really changed. But as you get more experience, you'll be used to it. But we can see that the reference we added is showing up in there, so it was correctly added. Another clue we get that it was correctly added is that the error goes away on our using statement. So we should see both of those things and know that we're in good shape. So we've now said that this project is going to maybe use some of the classes that are available in the Forms namespace. Now we have to do one more thing on this thing to get it to let us display a message box, a cute little GUI window, and that's changing one of our project properties. So if you click on your Windows message box project, you can use the project menu and find Windows message box properties, or you can right click on the project and choose properties, or you can click on it, press Alt Enter. What we want to change in our properties is the output type. Right now our output type is set to console application. We're going to change it to Windows application. Now when we start creating Windows forms, we'll just choose a different template when we create our project so we won't have to do these things manually. These are just steps to show you how it can be done manually. And again, they do it in that chapter in that PDF document that I gave you, so I wanted you to know how. Now, if you look, it didn't really give us any sort of things to save, but we do have some outstanding changes, so I'll just click Save All, make sure it's saved those properties. To close out of this project properties window, just close the tab.
And it'll keep it saved
It'll
correctly.
keep it, yeah.
My form still has a squiggly line under it, but I have, I put that in there, so I don't know why.
Why don't you take over here? Let's share your screen and we'll see if we can figure it out.
Hello.
Okay, that looks fine. Make your Solution Explorer wider so we can see that whole. That looks right. Oh, good job. That's why I wanted you to share. You guys are so much better at figuring it out.
Okay, so what do I do?
So you got to add it to the project that we're working on, the Windows message box prop references.
You've also misspelled the class name here. There's a spelling error there. You're missing a G and an O.
But that's okay, as long as
Yeah,
it's
that's
the
okay.
same.
I was just
But
pointing that
click
out.
on your references there inside that project, not on the project itself. So the references right below. Nope.
Oh, here?
Yeah,
Okay.
and add the reference. Good eyes. You would not have seen that for quite a while. Austin's on it. Okay, so you can quit sharing and exit. You didn't check it. You didn't put the check mark by it.
Oh. I have to go back to the reference.
Uh-huh. There it is. Ah, good job.
Okay. Thank you.
All righty. Thank you guys for sharing. I really do think it's faster because I just stare at them and I'm like, I don't know. All right, so in this project, what we're going to do is very minimal. We're going to set up an array of strings called names, and we're just going to put a few names in there. Short names. And for this project, we're going to be using a message box control, which is a little different than outputting things to the console. So let's go ahead and set up a string called message to hold our output. And we'll make it a null string or an empty string to start so that we can just add to it in our ForEach loop. Speaking of, let's go ahead and create our ForEach loop. And we're looking at one of the names in our names array. And we're going to add that name to our message plus a new line character. Now our message box command or class name is actually message box. And when you type that in, type the dot, you should see it change to the aqua color because Visual Studio UI should recognize it as a class name. And as soon as you type the dot, it's going to show you the properties and methods available from that class. Well, there's not much. It looks like we're going to use that show method. That's about the only choice we have. So messagebox.show. Yes, sir?
I'm noticing you're doing message box as opposed to Windows message box. Right?
Uh-huh.
When I named this class to begin with, I just named it message box. Do I need to change that?
You might.
Okay.
It might not care.
I'll just go ahead and
And be safe there.
rename it just to be
Good catch.
thorough.
Very good catch. Now, when I'm sitting here inside my parameter, parentheses for my messagebox.show, I have a whole bunch of IntelliSense stuff showing. That's because this method has a lot of different overloads. Each of these is a different definition of this method in the message box class. I could use the show with just text. If I scroll down, I would see more options. And I could keep going, but I want to try just some text. So no matter what overload I look at here, the first thing the message box show method wants is a string of text, and that's what's going to display. Well, what text do we want to display? Our message. We already built it. We have it set up in our message variable. So let's just use that. So our message should already be built with all 3 or 4 of our names in it that we have. Now let's run. Oops. I'm getting the wrong project on my Windows message box. I need to set it as a startup project. And then I'll try that again. Now you should see the cute little message box. It doesn't look much more graphical than the console display really, does it? So let's make it a little bit better. Has everybody got one showing up?
Not yet. My laptop is slow.
Okay, let's fix them. What's the matter with it?
Oh, no, I didn't. Oh, there it is. Oh yeah, it works. I normally with the console apps in the habit of doing Control F5 because then you don't have to put the read key at the bottom. It does the, but I guess you don't have to do that with the Windows app.
Nope, don't have to. Makes life better.
But now I have to change my habits.
I know. All right, so our message box shows it's kind of ugly. But if we go back into the parameters for our message box, let's type a comma. And I'm looking at all this IntelliSense. I see that the next thing is a string that would be the caption. So let's give our message box a caption. Let's call it list of names, because we're still all Irishy from St. Patrick's Day. Now let's run it. And we should see that as our heading, our title of our message box. One last thing that we can add to our message box, super easy, are some different buttons. Because right now we're just seeing that OK button, which is fine. And for what we're doing, it's probably perfect. But we could add some different buttons if we wanted to. So by default, we could add like yes, no buttons. cancel buttons. Let me click on it and see message box buttons. The IntelliSense option will give you a whole list of all the different options that you have. You could do a retry more button. Okay, okay, and cancel.
Can we-
Retry, cancel. Yes, no, and yes, no, and cancel. Now it'll take us a while before we get to a point where we're understanding how to read what button they clicked. But for now, let's just pick something to display a different one. Yes, sir?
Question.
Uh-huh.
Is there an easy way at this stage to make a button that just says whatever I tell it to say? Or is
Not on the message box.
We're not there yet?
You could, right, but in your message box, you could make your message say something so that the yes or no button sufficed. Does that
So we
make
just
sense?
need message box buttons then.
Mhm. Okay, run it again and see if you've got your yes, no buttons. And now we have our list and our yes and our no. Okay, so like I said, you do not need to do the message box for the assignment that's due in hypergrade. Don't do the message box for the assignment that's due in hypergrade, because hypergrade doesn't like Windows Forms stuff. I just wanted to show you how to do this for those Chapter 7 examples that are listed in that PDF that I posted for you, okay? So you do not need to do this in that project. But it's a good example for you. So let's save everything and close all of this. And before we close out of the solution, I didn't mean to close that, sorry. Let's create one more new project.
Another one?
Another
Oh
one.
my gosh.
You're just going to be project to death here. Now, this project is going to be one that should be very similar to the homework assignment.
What kind of project are we making? Is this another console
It is a
app?
console app. And the one that's due for your assignment, you see if I can bring it up in hypergrade. So you can kind of have a visual on how similar it is. And the one that's due for your oh my goodness, where is it? There it is. So you're going to be creating a loop, prompting the user for homework scores. All they're going to be entering is a number. The number has to be between 0 and 10. As they enter the numbers, these are homework scores, you're going to save them into an array. When the user is done entering numbers, you're going to use a loop to traverse your array and total up all your scores, calculate the average for the homework scores. The only caveat here is that you're not supposed to include the highest and lowest scores in the average. You are, however, supposed to print those ones out, the highest and lowest. So this application that we're going to create is going to be really similar. We're going to do the prompting of the user to ask for the scores. We'll be doing a lot of the same things. So let's see what we want to call this one. In the book, they called it average diff. So let's call it that so you'll recognize it if you're looking at that PDF document. Now for average diff, I want to rename my program.cs to be the same. And I want to set this project to run at startup. One last thing, I want to change my using clauses to add the using static system.console. Now in this project, in this example, we're going to be focused on the array aspect. So everything's going to be in the main. Bad, bad, bad. But we won't have methods or classes or anything like that, and that's fine for you for your turn in, because what matters here is that you have an array and that you're using that array to save these scores. So that's what the focus will be on for this particular assignment. Now, in order to do what we need to do, we need an integer to hold our total of all of our scores. This application that we're going to do is going to be a little bit different. We are going to calculate the average of all of the scores, but instead of eliminating the highest and lowest scores, we're going to do another calculation to determine how far each score is from that average. What's the distance from the average? So just a little bit different so that you have to do some thinking and some work to get it converted over. We're going to have a string to hold our input value from our user. And finally, we're going to have an array of integers to hold the scores. By default, we're going to set this thing to have 10 entries in our array, but we might change that as we're testing. Now, first, we're going to be asking for input. Our input is going to be controlled by a for loop. We're going to run our for loop with an integer named I that we're going to initialize to 0. We want to run while I is less than the length of our score array, and we're going to increment I for each iteration. So how many times is that for loop going to execute? Nine times? Nine times? What about that time when I is 0? Wouldn't that give me 10 times? And remember, this is our off by 1 error, so come up with a way that works for you to get over that, because it's really common to come up with that and say 9 times. For me, I'll just kind of think about what the first number is and what that last number is, and I can kind of do a visual internally on what's going on there. Sometimes when you're sitting in a test question, you're like 45, 46, 45, 46, which is it, which is it? And you have to really, really think about it. So write something down, whatever helps you to write something down. You might do subtraction, if I can say that correctly, to get it right. Yeah, this one will be executing 10 times. If our less than sign was not a less than, if it was a less than or equal to, we would execute 11 times, which would be 1 time too many. So that's why it's set as a less than. Now, in this loop, whoops, we're going to write out a message first, prompting for a score. In this message, I want to have the score number printed as part of the prompt. So we're going to use a parameter there and say enter score whatever. Well, to replace our parameter, let's use our I plus 1. So that way, when I is 0, we'll be saying enter score 1. When I is 1, we'll be asking for score 2. So we'll always be asking for a number higher than what we're going to save that array. Now, whenever the user types in their data, we want to read it into our in-value variable. We set that up as a string, remember. Now we're going to use the try parse, but this one we're just going to do a straight if statement. So we want to check to see if we can take that in value and parse it as an integer. So we want to do an int try parse. The data that we want to pass our try parse is our in value variable. Now, if that parses is a valid integer, we want to output it to our scores array and just load up that entry that we're pointing to with our current value of I. Now remember, if the try-parse fails, it'll load the value of 0 into that array entry. If that try-parse fails, it's going to return a false. In a lot of our earlier code, we just used the exclamation point to check to see if it was not true. We could also say if it's equal to false. Same thing as what we were doing before. So if we get a false from our try-parse, we're going to output a message that says invalid data entered hyphen. And I want to add a little bit more to that. 0 stored in array. Now at this point, I don't need to worry about that score entry. It's already got a 0 in here because my try-parse took care of that. It either contains the value that was typed in, converted to an integer, or it contains 0. There's the end of our if statement. And then after that, we have the end of our for loop. So this is our input loop. It would be a great method, right? Because we could just load up that array. But it's fine here in our main. So now that we have all our input, let's walk the array to sum up the numbers. Reverse the array to sum the numbers. So again, we can use a for loop. We'll use our same integer, I, starting at 0, running while it's less than the length of our array, adding to I as we go. In this for loop, we're just going to add to our total this score. Now the IntelliSense, or whoever is complaining on us, has some squiggly lines up here. If you mouse over that, it'll suggest that you replace this with ForEach, which would make sense, right? The only reason that we want to do it with the index value is just that extra practice, that extra having that experience of knowing that we can do it that way. But yes, we could replace it with a ForEach, and it would be a little bit easier to understand. But that's the end of that for loop. Now that we have a total, we can calculate our average. We'll just use our total, and we'll divide it by the length of our array. Whenever we are looking at this program, notice that our for loop, our input loop, is going to run as many times as our array has entries. So if we leave this array at 10 entries, we're going to prompt for 10 numbers. So we can use that as our divisor, that length. If we had an array that wasn't completely full, we might not be able to. We might have to count those entries separately ourselves to be sure that we had them. But for this one, we can. Now I'm getting this weird baby blue squiggly. What's it complaining about? Data loss. What's it saying there? So our total is an integer, right? Score.length is an integer, right? What about average? Is it an integer? It's a double. So how can we get the decimal place, the decimal value out of that divide function if we're only dividing integers? Cast it. Perfect. And we can cast either side of that equation. It doesn't matter whether we cast double or whether we cast that length. As long as we cast one of them as a double, everything will work right and we'll get our decimal value out. But if we just have 2 integers on that division, we're going to have truncation occur. We're not going to get that decimal. Now let's put in some code to output that average. First, we'll do an empty right line, and then we'll do a right line. Average with that parameter 0. And what we want to replace our parameter 0 with is our average value, but we want to convert it to a string, and we want it formatted as a fixed point with 0 decimal places. So gripey at us, we're okay with that. I'm going to put a read in after that to make it pause so we can test it. Now, before we test, I don't really want to type in 10 numbers. I know you guys love typing in numbers, but let's change our array size to like 3. That should be enough. We can test that way. Okay, let's run it. I want 20, 30, 40, and my average is 30. So that looks right. How's everybody? Good, good, good. Okay. Ethan, you okay back there? I didn't know if I'd lost you behind all those monitors. Just dropping down. Okay, good. So this looks great. We've got all of our scores in. Now, the other thing that they said they were going to do on this one is they're going to compare each of the scores in the array to this average. Right now, at this point, where we are with our program, we really didn't need to save these scores to an array, did we? Because we could have just added them up as they were being entered. Then when we got done entering them, we could have calculated our average. Yes, sir.
For some reason, my if is still printing out, even though I'm entering integers.
Your what's printing?
The if. Yeah. Better.
Oh, you didn't change that.
Yeah, it's working.
Let's do test that though. We should test and make sure that our if statement handles invalid input. Let's try it. I'll run it again and put 20 and then something bad. And it says, sure enough, it didn't take it. And then I'll put in 10, and 10 should end up being my average because that middle one got 0. Great. So now we're going to loop through our array or step through our array and print out each number with how far it is from our average value. So we want to output a couple more things here. Output how far the array element is from the mean or average. I'm going to output a blank right line again. And then I want to do a right line that's going to be kind of a heading. So it's going to say score and then have a tab character and say DIST, meaning distance from AVT. Now that we've got our heading output, let's do another for loop. In this for loop, the first thing we're going to do is calculate our distance. Now our distance is going to be the average value minus this score. So if our average is 7 and this score is 5, that distance will be 2 and that'll be correct. But if our average is 5 and this score is 7, our distance would be -2, which will look weird. So let's change our output here to use the absolute value, math.abs, so that we always have a positive result. So nothing special, just making sure that we're not displaying negative things. Got an extra parenthesis. There I am. Now that we've calculated that, our final right line, I'm going to use the, whatever thing that is, interpolated, and I want to print out the score at position I, plus a couple of tabs. Then I want to print out our distance variable that we just calculated, and let's convert it to a string, and again print it as a fixed point with 0 decimal places. And our read should be after all of that. So I should be able to put in 40, 50, 60, and I should see my distances and my averages and everything come out looking pretty much the way we want it. Is it all good? Everything's working? Now it's different than what you need for your homework. So where is it different? The first thing is up here when we're inputting data. You're going to need to validate that it's a valid integer, but then you're going to have to add additional validation. You have to make sure it's between 0 and 10, right? So you won't be able to use this code exactly. Then you can use the calculating the total and the average, probably decide how that is working. But then at the bottom, you're not going to need to do the distance. You're going to need to figure out how, when you're calculating the total, you can eliminate that minimum and maximum value and keep them to print later. So you might need a min variable and a max variable. You need to keep track of those values. So you can take this code and change it to be the assignment, or you can start fresh and just refer to this code. Totally up to you, but remember, sometimes it's harder to change something than it is to just start from scratch. So that's your choice. It can be rough. So I want to save it all, and I'm going to close everything. And we're going to do our lab today looking at that PDF document. So the way this thing works is, at the end of each chapter is kind of a really complex chapter project. So I'm going to go to the end of chapter 7, and we're going to work on this complex project together so that you can see some of the things that we can do. Let me find it. Okay, so here it is. It starts right before page 418, if you can get that PDF open. Now, we definitely won't get all the way through it, but we can get started a little bit on it. So this is a good project for us because it uses arrays and it uses a separate class. So it gives us some more practice with that because, of course, we need more practice with that. Whenever we're looking at this application, let's think about what it's doing. It's a manatee application. What it's going to be doing is tracking sightings of manatee. So if we get a reported sighting, we're going to be keeping track of the date, the location, and how many manatees they saw. So if they see 15 of them or 8 of them or whatever. So that's our job here. Our mission is to log the viewing or the sighting of manatees. Our output then would look something along the lines of this. For this given location, the average number of sightings was 10. The month with the most sightings, the date of the most sightings, and the count for that date. How many sightings were there? So I'm not sure when manatees are out and viewable, but I'm sure certain times of the year. So we'll see how that goes. So in order to clarify for us what we have going on, we have some class diagrams or a little bit of UML diagram, kind of a mixture between the two. We're going to have 2 classes, 2.cs files in our application. One will be our Manatee app. That's going to be our tester or our driver app. So it's going to have a few variables like the location and the count of sightings and how many manatees were seen. And it's going to have one method, a get data method. But basically, this is just going to be our driver CS file, not doing too much work. Our manatee sighting class is where our work's going to be happening. So for any manatee sighting that occurs, we're going to keep track of the following data: the location, the date, and the count. Notice that the date and the count are both arrays. So for a given location like Australia, we might have 12 dates that sightings occurred, and we could have different counts for each of those dates. So that's how that's going to be set up data-wise. Now, as far as methods go, we're going to have several methods within our manatee sighting class, like how to calculate the average and get the index of the day of most sightings. And we're going to override our toString method. So we can see a lot of our work is going to be happening in that manatee sightings class, which makes sense because it's going to have all of the information about these wonderful manatees. So let's create our new project. Has anybody ever seen a manatee?
Yes.
Did you see one like on the ocean or in a zoo?
6 feet away
In
in Florida.
Florida?
It's a big pond and they don't move.
So he was in the ocean? Just gonna fight you for spot?
Bunch of them.
Oh, cool.
They don't
So
move.
see, you could have reported your sighting. I think that's why there's not very many of them, because they're not real movable, huh? They stay in the way. Okay, for our new project, we're gonna make this a console app. And our solution name let's call it listing. Oh, wait, where am I? Just a second, let me find it. I'm in the wrong place. I think we want it to be manatee app, but I want to make sure because I want you to be able to tie it to this thing. So many places. Yep, manatee app is what we're going to call it. And I'm going to name this project manatee app also. You don't have to get the weird different names for these. So let's rename program.cs. And this again is going to be our driver file, and we'll call it Manatee app. We'll come back to it. Let's go ahead and create our Manatee sighting class, because again, that's going to be where we're going to be doing the majority of our work. So I'm going to right click on our project and add that class and call it Manatee sighting. I'm going to put that that's from that PDF, and our date. I know that's really explanatory, but we know what it means. Our purpose is to track manatee sightings. Whenever we're working with a class file, there are some special commands that we can use to kind of organize our code. And I want to use those in this one. We hadn't used them before. So we want to use the region statement, and it starts with a pound sign. So type pound sign region or hashtag region. And then I'm going to say in this region statement that our private class fields or instance variables will be under this region. And then I want to put an end region statement to match it. And as we add some code in between these, you'll see how it works and how it's going to help us organize what we have. Now, these are called compiler directives with the hashtag at the beginning. That means they're not C# code. They're just statements that the compiler will see. And the compiler will see them and say, oh, do I need to do anything about this? Yes or no. And it will do whatever it needs to do or not. And then it will just ignore those statements, so they won't have any impact to us. Yes, sir?
Never mind.
Why it won't, it's not letting me zoom. I'm scrolling instead of zooming. All right. So now what I want to put in between the region and end region are going to be our private class fields. For our main sighting, we only have 3 class fields that we have to keep track of. We have a string. It's going to be the location of the sighting. We have an array of strings. That's going to be the dates that those sightings occurred. And then we have an array of integers that's going to be the count of manatees that were seen on those given days. Now, those are our private class fields, our instance variables for this class. Notice that we put the region and region statement in. Now we have a collapse point there, so we can collapse those down or expand them. And that way we can just kind of control what code we're looking at a little easier without having to scroll through so much all the time. So we'll keep doing that for our classes to keep everything organized. It also kind of serves as like a comment. So our next thing that we need to add in our class are our constructors. I'm going to go ahead and put the end region statement in so that I don't have to worry about it later. Now our constructors allow us to specify what kind of data we need to build instances of our class. So we can have as many different constructors as we want. The first one that we're going to have is a default no-arg constructor. The default no-arg constructor is always public and is always named, every constructor is named the same as the class. So manatee sighting. And then no parameters. So that default no R constructor means, because I have it there, somebody could create a manatee sighting instance without supplying any information, the location, the date, the counts, or anything. It would just all be empty. And then they would have to update that sighting instance to include that information for later. So let's create another constructor. Let's create a constructor that requires the location. So again, it's going to be public, manatee, sighting. But this one requires a string, and it's going to refer to it as LOC, or location. Because a location was passed to us, we're going to use it to update our instance variable, our class variable. Now in our default no R constructor, we could have had code that says location for default location, count equal to 0 whenever we wanted. But for this example, the decision was made there wouldn't be any default value set. So it will just be an empty instance of that manatee sighting. Now we are going to let them also create instances of manatee sightings that only have locations. And then again, they can come back later and update the dates and the count. Now another constructor we're going to have is going to include all data. So this one is going to be a bigger constructor. In this manatee sighting, we're going to say that you have to pass us a string that's the location, an array of strings that we're going to refer to as the date, and an array of integers that we're going to refer to as CNT for count. So this constructor has a lot of data. First of all, we can set our location variable to whatever was passed to us in the LOC field. Our other things, however, are going to be a little bit harder to set. We're going to use site date. If we scroll up, we should see that is our string array. We're going to allocate one of those. And for this manatee sighting, we're going to allocate that as a new array of strings. And how many entries are going to be in that array are going to depend on how big the array is that was passed to us. So our parameter array of date, however many entries it had, that's how many entries we're going to put in our site date array. Now we're going to do the same thing with our manatee count array. It's an integer type array, and we're going to set it equal to the length of the count array that was passed to us. And we have these arrays being passed to us with data in them. So we might have these dates being passed in that array. If I try to set our new array equal to the date array that was passed to us, what will happen is the date array is pointing to a specific location in memory. Let's say 0F Charlie 9. That's where our date array starts, right? That's its reference point its pointer, it starts in memory there. If I use this statement, set my new array equal to this old array, that will work, but all it will do is set the reference of the new array equal to that same location. So now I basically have two array names pointing to the same array. So if I update it, that update will be reflected in both of those names. I can't just set an array equal to another array to get a copy of that array. I have to actually do a copy function to get it to where I have a whole new memory location for the new array, Charlie 9 dog 7. So that he now is pointing to a new copy of it. So we're going to do a copy statement for our array. That's why. So we're going to use the array class and say we want to copy. Now, what do we want to copy? We want to copy the data array that was passed to us. We want to start at index position 0 of that array. We want to copy it to our site date array, starting at position 0. And the number of elements we want copied are all of them. So we're going to use our length of our array to determine that. I cannot type that. There we go. So we could put a comment up there. Let's do it. Copy from array, index location, to array, index, and then finally length. Because we might not want to copy every entry in our array, but in this case we do want to. So we're going to use the length of our array as the number of entries to copy. Now the array.copy and some of the other array methods that are available to you are explored in those example exercises that are in the chapter. So that's why it would be good to take a look at them. Now the second array I want to copy is the count array. And again, I want to start at position 0. And I want to copy it to our manatee count array, starting in position 0 for the length. And the length is determined by our manatee account, manatee count long length.
Uh-huh.
And I don't know why we use the long length in that one.
Why are we using the long length in
I
that
don't know,
one?
other than to show you that it also exists. That it's a long variable instead of just an integer. So if you had a super huge array, you might have to use that long length.
I need to phrase my question differently. Why are we using the manatee count on the last one and not the one we're copying from?
And that's a really good question. And the deal is it doesn't matter because we already set it to be the same size.
Oh,
But they did swap which one they were using when they went back and forth like that. So the first one does the original data array, and the second one uses our class array. Yeah, consistency. And actually, sometimes I think they want to be inconsistent to show you, look, it doesn't matter, you know, because they're both the same right now. But I think that we're using this long length variable because we could have lots and lots of sightings. So that array theoretically could be really, really larger than the number of they could be. And so if we had an array that was too big for an integer to hold the value, we would need to use the long length. But it doesn't happen very often. It would be a huge array. Okay, let me zoom out just a little bit. So we've been working on our class here. We have our class fields set up. We have our default NOR constructor, our constructor that uses the location, and we just created a constructor that uses all the data. We're going to create another constructor just like this one, just a little different. So let's create it, and then we can look at how it's different when we have something to look at. Now for this constructor, again, I want a string that holds the location, an array of strings to hold a date, an array of integers to hold the count, but we're going to add one more variable. And this is going to be the num of flights. So if we use the method, our constructor that cares about the num of flights, we're going to be able to use that number parameter as our length instead of having to use the length of the arrays. So we can set our location, and then we can set our site date array equal to, instead of using the length of the array that was passed to us, we'll use the num of flights that was passed to us. For some reason, I have to transpose every H and T today, because there's lots of them. Okay, so there's our site date. What about our manatee count array? Let's do the same thing. We'll say it's a new array of integers based on this num of flights variable. Now we still have to do our array.copy things. Copy the date from 0 to our site date array from 0. But this time, again, we can use our num of flights variable. And our second copy, we're going to take our count array starting at position 0, copy it to our manatee count array starting at position 0, and again, the num of flights is going to be the number of entries we want to copy. No, because this num of flights is an integer, and so it's not how all of these are. I don't know if they're like helicopter flights that are viewing manatees. That one I hadn't quite figured out yet. All right, so this constructor is almost the same as the previous one, except that number. So let's put a comment in like that. And we'll say constructor that includes all data. And let's just put something like flight data, because we know this has to be coming from a little bit different of a place. And sometimes that might be all we know is the developer too. We might be given a UML diagram like this or a class diagram and told, okay, develop this class. We don't actually necessarily know how the details behind that data are going to work out. But our class is looking beautiful. We have some really intense constructors, and we didn't get very much practice with constructors when we were working on classes, so it's always good for us to get more. So now let's add another region. Our constructor region is done. We need a public properties region. We've set up all of our class variables as private because we don't want other classes to be able to change them. We know how our class variables work. They don't. They might mess them up. We have the appropriate logic to handle and maintain those class variables. They don't. So our public properties give us a way to allow other classes access to our data and the ability to update our data, but we can still control it. So the first property that we need is going to be a string property for our location. Now, we've had a lot of property problem with our wonderful third-party products with Hypergrade and REPL, so that hasn't been helpful. So right now, neither one of them are being able to handle the properties with the Lambda expressions built in their syntax. So we're going to use the old style property syntax. Either way should do the same thing for us in Visual Studio. We just have that problem with those third-party products. Yes, sir?
Is it important to make sure that the public version of a variable has a different name from the private version?
Yes, because otherwise you'll just create a never-ending loop where you're trying to access that variable, you're trying to access that variable, and you're trying to access that variable, and it just kind of gets stuck in the property. So if they're not the same, you'll get to an infinite loop, but you won't be able to find it if you don't have loop code. But when C# is trying to do that automatic stuff for you, it will get very confused. Now we have our getter, which is automatic. We're saying if somebody tries to get this property, use this code. And all we're saying is, oh, this location property is associated to our location class field. So that's the field we want to return. If somebody wants to update the location, we want to use the value that they supply to update our location variable. So not too much different than the properties with our Lambda expressions, just enough to really throw you guys a whammy. Now the next one that we need is our string array site date. So that's why the convention is to name the private class fields with a lowercase letter and the public property with an uppercase letter. But you won't see that everywhere because it's just a convention. Now in our site date property, if somebody wants to get our data, we're going to return our site date array to them. And if they want to set something, we're going to take that value that they give us and put it in our site date array. And one last, because we only have 3 class fields for this one, is our integer array, manatee count. Now for our manatee account, if somebody wants to get that, we're going to return our manatee count array. And if somebody wants to set it, we're going to update that array. Now, if our properties are making us mad and we don't like them, we can just use that region to collapse them down. And of course, we could collapse each individual property. The IDE was already giving us that collapse point, but we just kind of made our own with that region, saying that we want to be able to close down all of our properties so that we can open them if we want to see them, but otherwise get them out of our way.
Is that then the only thing that the little region tag is for, is just to, it does literally nothing as far as the code. It's,
right.
It's a glorified comment almost.
Yep. Yep.
Okay.
Totally.
I was very mystified by that.
That's all it is it gives us that point to just collapse down. But it does act a little bit like a comment, so we can see what's hidden.
But it doesn't actually do anything then,
right?
Except let Visual Studio collapse it.
Yeah,
okay.
The compiler will look at it and say, oh, I don't have to do anything about this, and just get rid of it. So we don't have much time. Let's look at our Manatee app and see if we could maybe, I'd like to construct one instance, but before we do that, we better create our toString method, or we won't be able to tell that we did it. So one more region.
I'd also like to stop you briefly. On my screen, I've got all these Lambda operators for the public properties, and it likes them fine, but you've got all the squigglies, and it doesn't seem to like it very much.
For these?
Yeah.
Oh, it's just complaining because I'm not using the Lambda. That's why they're all green. So they're all fine. They're just saying, you know, you might want to use this other alternative body style, using those really cool Lambda expressions that nothing else will handle.
But yeah, I've got the exact same expression on mine, except I've changed the variable names of what I'm using.
Expression body.
But I don't have the
Yeah, I
squiggly
mean,
lines.
does it want it to be on a separate line? I don't think so. I think it's just the Lambda expressions that it's complaining about. Oh yeah, tell us what it wants. What's it want? Yeah, to expression. It wants to give us that. Let's see what the preferred body style is. I'm not going to mess with it because I did it there a few weeks ago, and then my example code was messed up the next few days. So I'm not going to listen to resharpen right now. But I am going to put in a region statement to say we're going to create some instance methods, and I'm going to do my end region.
So what exactly do you mean by an instance method as opposed to some other kind of method?
Well, when we create a method in a class, that method is going to exist in memory once for every instance of that class, right?
Yeah.
If we create a static method, it would only exist in memory once. So that's the difference.
So for a regular method, it's just some random thing it does. An instance method is we're going to do something to this instance of the object. Okay.
Applies to this instance. So the first thing we want to create is our override of our toString. And we'll make it a little quick right now, and we'll come back and add more to it later. Let's do, the first thing we want to return is a tab with our location. And I'm just going to end that toString there, and we will add more to it as we go. So now I can use our Manatee app to create a really quick basic test. I'm going to say that I want to create a Manatee sighting instance. We'll call it Site1, the new Manatee sighting, and we'll say it happened in Australia. Now I want to use our toString method, so I'll use the console.writeLine to output Site1, and make sure you make it GHT, since I'm having trouble transposing those letters. My normal thing that Word always corrects me for. So we should see that we get our Manatee sighting created, and then our output should just print out that location. I better put a V there, huh? There, I've got something. There's my location. It looks like it's doing things the way we want it. So that's going to put us in good shape to finish this up on Monday. Now, before then, should be looking through Chapter 7 in the PDF document, looking at all the practice activities that are in there, and you should see that you can get a much better, nice, warm, cozy feel of understanding things if you look at this PDF document compared to the textbook that we've been trying to work with. So this one we'll use for free, and try to do the best we can with it. We'll finish this up Monday, and then we'll start on using TFS and getting to where we can capture any sort of exceptions that might result from our code, so that we're all set to start with our Dewey apps after our Unit 3 exam. So work on Chapter 7. Any questions with this one? Is it working so far for everybody? Problem? Good. Okay. Get you out of here then. Make sure you save it. And I'll see you Monday. So
What were you saying about just submitting the REPLs?
just submit them if they're working. It's just that garbage that
Yeah,
you're saying,
okay.
yeah, just go ahead.
Do we know why that's happening?
No, they're working on it. So go to repl.it/bugs
Okay.
and upvote that problem so that they know how important
That
it
happened to
is.
me on the earlier REPL. And I was
Uh-huh.
like, no, it's back.
I know.
I never
And it's
saw the
real
difference.
random. It doesn't seem to have anything
Yeah, I
to do
tried
with you
resetting
at all.
everything, deleting all the
It's
code.
just like if it's happening, it's going to keep happening. So yeah, you're okay to go ahead and submit it. I hope they get it fixed fast.
Yeah, me too.
They said a week or so ago that they were switching and using more robust virtual machines. I would say it probably has something to do with that. So hopefully they can fix it.
Right.
You know, my thing about these systems and seeing how many people are having a certain problem is a lot of people use that just to like tell, well, since only 3 people are having this problem, they're not doing anything. I would more robust. Because then those certain 3 people, that can be a very long problem.
Oh, it could be.
And
Especially if you've got a site like that, you better be keeping up because that's a really big problem. They should have gotten on it, you know, like immediately. Oh yeah, that's why keep telling everybody upvote it because they just let it sit out there for like 2 weeks without even worrying about it.
I wanted to ask a thing about the class schedule in general. File handling is a thing I'm interested in figuring out. Is that a thing we're going to be covering in class in the near future, or should I just be looking that up over the weekend?
We won't get to it till towards the end. So if you want to get started looking it up, it'll be, that's one of our last things.
Thank you.
So, sure. I didn't get your email. Was it the garbage coming out in REPL, or were you having some other problem? I see your email. I just hadn't.
Yeah, it just, I think the last 3 of them has that issue. Like,
So just submit them. If they're working right, it's just giving you those weird characters.
so I'll do it on Visual Studio and submit it.
Fine. Yeah, no, you can just submit it in the REPL. Even just tell it to submit anyways, and I'll mark it as complete when I see it. So yeah, I don't know what they've got going on. Just a bunch of junk.
I thought I do something wrong.
No, it's not you.
And it would be great if we can upload the project that we're doing on the cloud or something, because I lost after you do the copy or anything. Just one or two line, it messes up the
that
whole thing.
PDF document that I sent out there, but I'll post it because we had so many people gone today. I'm sure we'll have people that will need it Monday, so I'll get it posted. No problem.
And about the static thing, I just found out that I just Googled it and they say the static is for controlling variables in class level, so we don't have to create an instance. But is it
quite understanding? So you could do that. You could do
I'm not
that.
sure I understand because I got confused about the get and set thing today. I thought I understand it.
Oh no!
When it comes to this thing again,
I got you again. So if we
Are you putting in the same number?
say in our Manatee citing class, we wanted to generate a random number, we could create a static random number generator at the top of our class, and then every instance of our Manatee citing class would use that same random number generator instance. So we could control how many random number generators were loaded into memory, that we would just have that one. So we would want to make that a static thing. And we don't need to have a separate one of those for each manatee sighting that we might see in our class. Does that make sense? We need to have a separate location for every manatee sighting that we see, but we don't need a separate random number generator. So we could make our random number generator static and use the same, basically, instance of the random number generator in memory for all of our manatee sightings, but we couldn't make our manatee sighting location static, or we wouldn't be able to have different locations. Does that make sense?
Not much, but I'm trying.
You're
I will
getting
try
there.
to remember what you say and think about that.
Okay, keep thinking about it.
That's how I do it.
Yeah, tell me what they say, because static has so much meaning
Yeah,
that it could
even
have
when I
more
go
meaning.
to Vietnamese website,
Uh-huh.
I understand more. It's still confusing.
It's still not okay, good, because that's how it is. Not that it's good, but it's just such a big concept. And there's apparently, we could write whole books about it, apparently, because there seems to just be.
Oh, I thought it's just like 2 or 3 pages.
No, it's a big topic. So to me, it's like a student, like if I had my Zoom session, which I need to stop here. Let me stop it.